I want to talk about quadratic functions. Quadratic functions are functions of the form ax squared plus bx plus c, where a, b, and c are all constants and a cannot equal 0. You'll notice that if a is equal to 0, then this term would be gone and you would just get bx plus c, which would be linear. What we know about quadratics is that the graph of a quadratic is a parabola. And to see what the most basic quadratic looks like, we're going to actually graph y equals x squared. So I'm going to make an xy chart, and I'm going to choose some values for x and solve for y. So we know that if x is equal to 0, 0 squared is 0. If x is equal to 1, 1 squared is 1, and so on. 2 squared will give us 4, negative 1 squared will give us 1, and negative 2 squared will give us 4 again. And we're going to plot these points on our set of axes, and we're going to get 0, 0, 1, 1, minus 1, 1, 2, 4, and negative 2, 4. And we're going to get a graph that looks like this. So this shape is called a parabola, and a parabola has a couple of different properties that we want to pay attention to. First, this place where it turns around is called the vertex. We want to be able to find that vertex. And it also has something called the axis of symmetry, and in this case this axis of symmetry goes straight down the middle so that we can see that it's symmetric on both sides. So in this case, our vertex is 0, 0, and our axis of symmetry, which is a vertical line, is x equals 0. So let's talk about these things in general for any quadratic function. Something else you might notice is that sometimes we see a graph that looks like y equals negative x squared. A graph of y equals negative x squared would look similar. We can see if we plot some points. If I plug in 0, I'll still get 0. If I plug in 1, I'll get negative 1. 2 would give me negative 4, just down here. Negative 1 would give me negative 1. And negative 2 would give me negative 4. And so while this is still a parabola, this parabola is going to go down. And the way we're going to know that in the future is this negative coefficient in front of the x squared. So if a is greater than 0, it's going to go up. And if a is less than 0, it's going to face down. Again, the interesting thing we would want to find is this vertex and this axis of symmetry. We weren't going to want to know where the vertex and the axis of symmetry are for different graphs. So let's take a look at y equals 2x squared plus 4x plus 1. We have a formula for both the vertex and the axis of symmetry. For the vertex, the x-coordinate is going to be negative b over 2a, and the y-coordinate is going to be the function value evaluated at negative b over 2a. Our axis of symmetry is going to be this line, x equals negative b over 2a. So let's take a look at this example up here and find both the vertex and the axis of symmetry. So starting with the vertex, we want negative b over 2a. So I am going to identify here that a is 2, b is positive 4, and c is 1. So for negative b, we would get negative 4 over 2 times 2, and we would get negative 1. Now that's just the x-coordinate of the vertex. To find the y-coordinate, I'm actually going to plug negative 1 into my equation, and I'm going to get 2 times 1 minus 4 plus 1, and 2 minus 4 plus 1 is equal to negative 1. So my vertex is negative 1, negative 1. And my axis of symmetry is x equals negative 1. That comes from this x-coordinate here. What would that graph look like? Well, we know it's going to open up because our a is positive. It's going to have an axis of symmetry at x equals negative 1, and at negative 1 is our vertex, so it's going to look like this. So something else we might want to know is some additional points, and we'll do that on our next example. Let's take a look at f of x equals negative x squared plus 4. So again, we're going to find our vertex, which is negative b over 2a, but let's take a look at this a little carefully. This is minus x squared plus 0x plus 4. So my a is negative 1, b is 0, and c is 4. So when we're looking at negative b over 2a, we're talking negative 0 over 2 times negative 1, which is 0. And when I evaluate my function at 0, I'll get negative 0 squared plus 4, and I'll get 4. So my vertex is 0, 4, and my axis of symmetry is x equals 0. So taking a look at this, we know that this x-axis, the y-axis is going to be an axis of symmetry, and at 4 we're going to have a 0, and it's going to open down. Before I draw that, I might want to know, where is it going to cross the x-axis? That's called an x-intercept. To find an x-intercept, we're going to let y equal 0, or f of x equals 0. So if I set this equal to 0, and add x squared, you'll notice I get x squared equals 4, or x equals plus or minus 2. So now I know that it's going to be wide enough that it goes through these 2 points. These are my x-intercepts. That concludes this lesson on graphing quadratics. Thank you.